Hello, welcome back. Looking at systems of equations, inequalities today. Here's my key here. Um, kind of a kind of a larger section. You're going to see systems of equations, inequalities all over the place. Some of them are going to be easier, some are going to be harder. They're kind of a mixed bag. You need to be able to look at it and say, "Oh, is this going to be brutal, or can I solve this quickly?" I'm going to do a smattering of these. Which of the following ordered pairs in the standard XY coordinate plane satisfies the system of inequalities below? Okay, so let's go through these one by one. Say x is going to be greater than 2. Well, right away, it's x comma y. Why don't you cross out the ones that aren't greater than 2? Congratulations, you got it down to 3. So I've done that. Y is greater than 0. Oh, well, that's equal to 0, so I can. All right. X plus y is less than 5. Well, here it's equal to 5 on D, and I've got the correct answer, C, by elimination. You need to be able to solve these things by elimination, testing each of the conditions. Each one of those things are like conditions. You got to check them. Okay. Fabric store sells flannel and calico fabrics. Great. F, C. Joan, almost said Juan, pays $25 for 3 yards of flannel and 4 yards of calico. Chris pays 11 for 1 yard of flannel and 2 yards of calico. What's the price of 1 yard of calico? What do I know? 3 flannel plus 4 calico is 25, and 1 flannel plus 2 calico is 11. You need to solve this system by either elimination or substitution. I think elimination makes sense here. What do you do here? You multiply all this stuff by, what are we going to do? Let's eliminate C. If we multiply everything by -2, what do we get over here? I'm going to rewrite 3F plus 4C is 25. You multiply everything there by -2, you get negative 2F minus 4C is 22, negative 22 rather. And when you add those up, your C's are gone, you get F equals 3. Once you know F is 3, you can go back and solve for C. 3 plus 2C is 11. Solving for C, you're going to find that 2C is 8, 1C is 4, so we end up with an answer there of G. Need to be able to set up systems of equations like that. What motivated me to multiply by -2? The idea of getting opposite coefficients. When you're trying to eliminate a variable, you want this situation right here, which is opposite coefficients. Come back and talk to me about solving via elimination if you struggled with number 2. Number 3 is a substitution question, but it's a hard substitution question. I think most of you would have looked at that ln and said, ooh, I don't know. Where does the graph y equals 7 intersect y equals 7? Where does it intersect y equals ln of x minus 2 plus 3? Well, you substitute. You say, okay, when are they equal? Well, I've got y in both of these. Let's just say 7 equals ln of x minus 2 plus 3. Great. If you don't know what to do with the ln, you can go ahead and skip it. If you do know what to do with the ln, isolate and solve it. You'll get 4 equals the natural log of x minus 2. You might need to remember that the base of the natural log is e. If you don't know what I'm talking about, just skip this problem. You would rewrite this thing then as e to the 4th equals x minus 2. Solving for x, you'd add 2 over. E to the 4th plus 2, answer's got to be B there. But if you looked at that ln and said, I have no earthly idea what that ln means, Mr. Kraviec, that's fine. I'm not going to worry about teaching you about the natural log for the 2 problems you might see it on. I do want you to be able to do that first step, though. Y equals 7, y equals ln of x minus 2 plus 3. Where do they intersect? They intersect when they're set equal and solved for. So if you see intersection, set the 2 things equal to one another. That's a big word there, intersects. A couple more. I wanted to look at numbers 5 and 6. We'll look at number 5 because it doesn't ask you what you think you're looking for. What's the sum of the solutions? You know, you solve this first one, you get x is 3 over 2. You solve the second one, you get y is 6. But that's not either answers. You got to add those together and get, you know, answer 7.5. But the question that I wanted to look at was number 6, because I had, you know, I looked through these problems before I go through them with you. This one I had to sit and think about it for a second. I said, what the hell? All right, if they are, all right, for which of the followings will there be more than one solution? So I saw more than one solution, and I thought, okay, I got a quadratic thing. And all these looks like, b squared minus 4ac. You might remember that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This thing up here is called the discriminant. And if it's positive, you're going to have two real solutions. So what do? I take this equation, solve it for y, and I get y is equal to t minus rx over s. And I see that, okay, y equals x squared. So I set t minus rx over s. I set it equal to x squared. I go through and I solve it, and I get my equation for a regular quadratic, and I substitute s, r, and t in for my b, a, and c, and I get it. Answer is F. I put that in there because it was a question I had to think about. And most of you, I think, would look at that question and say, God, and then you just move on. But for those of you that were looking for a challenge, there certainly is one there. System of equations below has one solution, A, B. What is the value of B? You know, elimination, substitution. What are you going to find here? A lot of what we have here is elimination and substitution. I am not going to do a whole lot more of these. You need to ask me about elimination and substitution. I will look at number 12 here. Shaded portion of the graph, shaded portions over here, represents the solution set of which one of the following systems of linear inequalities. So we've looked at equations. Look at linear inequalities. We've got equations for two lines here, the -6 one and the +6 one. What is this? This line right here is y equals 2/3 x minus 6. I can tell because it starts down here at -6. And this line right here is y is -3/2 x plus 6. So we are above the line, we are above this line, we are below that line. So we're less than the 2/3 x minus 6. So less than, can get rid of the greater than. Oh, what's the slope of this thing? Down 3 over 2. Yeah. What's the slope of this thing? Up, what can you say? Up 3 over 4. Yeah, okay. So what are we looking for? We're looking for the one. It's less than the 2/3. It's greater than the -3/2. And it's answered right there, A. So I got to be able to say, okay, which one is it above? Which one is it below? What else might we look at? This is a lot of the same. 16 is a little different. Let P and Q be real numbers such that P plus Q equals 4 and negative P times Q is 12 and P is greater than Q. What is P? There you need to do some substitution. You might say that P is 4 minus Q, and then you could say, okay, instead of negative P times Q is 12, you could have maybe negative 4 minus Q times Q is 12, and you can set and solve it from there. You're going to eventually have something quadratic. What are you going to have here? Negative 4Q plus Q squared is 12. You set up and solve this thing for Q, and you can go back and solve for P. So we've got the setup for you here. The last step would involve, what? q squared minus 4q plus 12 is 0. You can go back and solve for q and get the answer here. So anything else I want to look at? Substituting in down here on number 17, what could you say? Given 3 over x is 12. Well, 3 over x is 12. All right, so what? 3 is 12x, and x is 1/4. Okay, well, if x is 1/4, 1/4 over y is 2. 1/4 equals 2y. Well, y's got to be 1/8. So we can substitute. We can solve things like this hopefully pretty quickly. Lots of substitution, lots of elimination. It's the same thing over and over. It's just the same dang thing over and over. You need to work through them and ask me questions about them. So we'll see you later.